The texture of space-time is rapidly changing, and before it can fully comprehend, it will simply tear apart. This creates a terrifying sense of awe as an infinite scene unfolds before us, captivating cosmologists around the world. Betelgeuse, the brilliant red supergiant that adorns Orion's shoulder, is undergoing an extraordinary transformation. Its iridescent glow, the defining brilliance of its celestial existence, has surged dramatically, surpassing its typical brightness by an astonishing 50% earlier this year. Once ranked as the 10th brightest star in the night sky, Betelgeuse now shines as the 7th brightest. Betelgeuse, a massive star nearing the end of its life, is so large that if placed at the center of our solar system, it would extend out to Jupiter's orbit. Eventually, this star will collapse in a supernova explosion, potentially forming either a neutron star or a black hole. The excitement surrounding Betelgeuse's eventual supernova is due to its proximity, roughly 650 light-years away, putting humanity in an ideal position to witness this cosmic event firsthand. When the supernova occurs, it will unleash a spectacular burst of light. Initially, a surge of neutrinos will travel across Earth, detectable by observatories worldwide. This will be followed by high-energy photons emerging from the expanding debris cloud. Betelgeuse will rapidly brighten over the course of 7 days, possibly reaching up to 100,000 times its usual luminosity. Depending on the explosion's power, this stellar event could rival the brightness of a full moon, and may even be visible during the day, casting distinct shadows at night. This cosmic event will last for an extended period, providing a rare opportunity for in-depth observations and potentially groundbreaking discoveries. While Betelgeuse's supernova may stir speculation and fear due to historical associations of such events with ominous signs, we can rest assured that we are far enough away to avoid any harmful effects. To fully understand the mysteries of Betelgeuse, we must revisit late 2019, when the red supergiant began to undergo significant dimming, an event visible even to the naked eye. Observations using large optical telescopes revealed that while the star appeared largely symmetrical, its outer layers showed signs of substantial disruption. The photosphere, which is the outer layer of the star from which light is emitted, exhibited significant disturbance. Additionally, the photosphere appeared to expand as seen from Earth, expanding at a steady rate of about 8 kilometers per second for most of the year, until mid-November 2019, when the rate of expansion began to slow. By mid-November 2019, the outward material flow from Betelgeuse stopped, prompting astronomers to capture new optical images of the star. These images revealed two striking anomalies. First, a dark region appeared in the star's southern hemisphere, creating a stark contrast with the earlier images. Second, the star's surface temperature dropped by approximately 80 Kelvin between January 27 and February 13, 2020, reaching an unprecedented low. After this dimming event, Betelgeuse gradually regained its brightness over the following months, eventually returning to its normal size. This raised the question of what had truly happened to Betelgeuse. The available evidence strongly suggested that the star had experienced an enormous and unusual event known as a surface mass ejection, SME. This event, similar to the solar coronal mass ejections, CMEs, involved a massive expulsion of material from Betelgeuse's surface. To better understand this, imagine a volcanic eruption on a stellar scale, where material from within the star surged outward, creating shockwaves in its atmosphere. Over time, this material formed particles and dust, partially obstructing our view of the star and making it appear dimmer. In Betelgeuse's case, the SME resulted in the release of mass 400 billion times greater than what is typically observed during similar events on other stars or CMEs. This mass was equivalent to several times the mass of the Moon, ejected at incredible speeds. Scientists noted that such a colossal mass release from a star's surface had never been observed before. This event allowed for direct observation and analysis of the star's surface details using the Hubble Space Telescope, offering unprecedented insight into the aging and evolution of a dying star. The SME had a profound impact on Betelgeuse, causing it to lose a significant amount of mass in one event. This demonstrated that a dying star can experience dramatic mass loss beyond its normal yearly decline due to stellar wind. It was as if Betelgeuse had forcefully expelled its outer layers and was in the process of slowly recovering from the aftermath. After this dimming event, the star's behavior changed. Previously, Betelgeuse would fluctuate in brightness approximately every 400 days, but now its brightness cycles occur every 200 days. Betelgeuse is classified as a semi-regular variable star, meaning it undergoes multiple periods of fluctuating brightness due to changes in its size and temperature. It is known to exhibit two primary periods of brightness fluctuation. The first, lasting 400 days, is believed to be driven by pulsations in the star's core, while the second, lasting about 5.6 years, remains poorly understood. Researchers have used virtual simulations to gain a deeper understanding of the events that occurred. They proposed that an unusually hot gas bubble, resembling a massive and intense air pocket, rose from within the star. Such gas bubbles occasionally form due to the star's violent and convective outer layers, which can be compared to a pot of boiling soup, where the material constantly moves and mixes. As this hot gas bubble ascended and broke through the star's surface, it triggered the release of stellar material. Interestingly, this event also disrupted Betelgeuse's regular pulsation pattern. The star's surface continued to expand while its deeper layers contracted, causing the pulsation cycle to shift from its usual 400-day period to a new 200-day cycle. Scientists speculate that the star's pulsation pattern will gradually stabilize over the next 5 to 10 years, ultimately restoring Betelgeuse to its typical 400-day pulsation cycle. As for the potential of Betelgeuse's supernova, astronomers predict it could occur any time within the next 10,000 to 100,000 years, based on factors such as the star's size, brightness, and estimated age. Researchers suggest that Betelgeuse is currently in the early stages of helium to carbon fusion, which is a crucial process in the life cycle of a massive star. The core of Betelgeuse consists of a combination cycle that releases enormous amounts of energy, ultimately leading to the star's dramatic end in a catastrophic supernova explosion. The potential for Betelgeuse to undergo such an event has been the subject of much speculation and research. While astronomers cannot predict the exact timing of this explosion, they continue to closely monitor the star for signs of impending collapse. A supernova from Betelgeuse wouldn't just be a spectacular cosmic event visible across vast distances, but it would also present a valuable opportunity for scientific study of stellar evolution and the formation of fascinating objects like neutron stars and black holes. Recent observations and studies have provided new insights into Betelgeuse's behavior and instability. For instance, the star's recent dimming and subsequent recovery raised questions about its internal processes and stability. The surface mass ejection observed between 2019 and 2020 was a key event that illuminated the star's dynamic nature and its impact on surrounding interstellar conditions. Advances in observational astronomy have played a crucial role in enhancing our understanding of Betelgeuse and other cosmic phenomena. Telescopes such as the Hubble Space Telescope and ground-based observatories equipped with advanced spectroscopic instruments have allowed astronomers to analyze the star's light spectrum in detail. These observations provide valuable data about Betelgeuse's chemical composition, temperature variations, and atmospheric characteristics. Beyond its scientific and cultural importance, Betelgeuse serves as a reminder of the vastness and complexity of the universe. Studying stars like Betelgeuse helps us unravel the mysteries of stellar evolution, from birth to death. It also provides essential information for theoretical models and simulations, refining our understanding of astrophysical processes under extreme conditions. In addition to its cosmic significance, Betelgeuse's visibility in the night sky has made it a favorite target for amateur astronomers. Its distinctive reddish hue and prominent position in the constellation Orion make it easily recognizable, even without advanced tools. Observing Betelgeuse over time allows enthusiasts to appreciate its variability and dynamic nature firsthand. The study of Betelgeuse isn't limited to visible light observations. Astronomers also use other wavelengths of light, such as infrared and ultraviolet, to probe deeper into the star's structure and surrounding environment. These multi-wavelength studies offer independent insights into Betelgeuse's physical properties and evolutionary stage. The star's recent transformation and variability have sparked renewed interest in understanding its long-term behavior and potential future path. Astronomers continue to monitor the star for any signs of significant changes or major events, with each new observation contributing to a broader understanding of how massive stars evolve and ultimately meet their dramatic ends. In the realm of astronomy, studying stars like Betelgeuse enhances our knowledge of stellar populations and cosmic evolution. Massive stars play a key role in enriching galaxies with heavier elements through processes like supernova explosions. By examining the life cycles of stars like Betelgeuse, astronomers gain insights into the origins of elements essential for planet formation and life as we know it. Looking ahead, future space missions and ground-based observatories will continue to explore Betelgeuse and other stars in our galaxy. Advances in technology and instrumentation are set to reveal even more about the inner workings of these stellar giants, from detecting exoplanets around distant stars to uncovering the mysteries of black holes. Our exploration of the universe is driven by curiosity and a desire to understand our place in it. Betelgeuse remains a celestial enigma that bridges scientific inquiry and public fascination. Its ever-changing nature, immense size, and potential for a spectacular supernova explosion make it a lasting source of interest and significance in the field of cosmology. As we continue to unravel the mysteries of the universe, stars like Betelgeuse continue to inspire awe and wonder, reminding us of the beauty and complexity of the cosmos. The process leading to a star's collapse begins with the fusion of elements like oxygen and silicon, ultimately reaching iron. When a star's core can no longer sustain fusion, it implodes under its own gravitational pull, triggering a catastrophic explosion. Since Betelgeuse is about 650 light-years away, any cosmic event there would only become visible to us after 650-year delay due to the limitations of light speed. This makes it unlikely that we will witness Betelgeuse's catastrophic end in our lifetimes. What makes Betelgeuse remarkable, however, is that we can actually observe its surface, which is not typical for most stars. This provides an incredible opportunity for astronomers to study the behavior of aging massive stars, particularly during events like mass ejections. Recently, astronomers made an astonishing discovery when they observed a star consuming its own planet, located 12,000 light-years away in the Ala constellation. Betelgeuse, with its distinctive name and prominent position in the night sky, has captured human imagination for centuries. Its name originates from the Arabic term for armpit of the giant, though some researchers suggest it may represent a hand or shoulder instead. This connection to body parts is reflected in various interpretations across cultures. For example, in ancient Japan, it symbolized a severed limb, while in Brazil, it was associated with a turtle's leg or a caiman's hind leg. In Sanskrit, Betelgeuse is linked to the wet one in Hindu astrology, associated with the storm god Rudra. Throughout history, Betelgeuse has held cultural significance in various customs. In Macedonian traditions, it represented domesticated animals and agricultural life, while in regions like North Baffin Island and the Melville Peninsula, its rising marked the arrival of spring and longer days. Betelgeuse's association with the Orion constellation, where it is recognized as the star on Orion's right shoulder, further amplifies its cultural relevance. As one of the brightest stars in the sky, it continues to inspire artists, writers, and creators. The potential for Betelgeuse to become a supernova in the future is of great interest to both astronomers and enthusiasts alike. As a red supergiant, it is one of the largest stars known, with a diameter about 1,000 times that of the Sun. This size is due to its advanced evolutionary stage, having exhausted much of its nuclear fuel. Despite its considerable distance from Earth, Betelgeuse remains one of the brightest stars visible in the night sky. Its brightness fluctuates due to its pulsations and occasional mass ejections, providing valuable data for astronomers to study its physical properties and gain insights into the final stages of stellar evolution. In addition to its scientific significance, Betelgeuse holds a prominent place in cultural history. In Arabic astronomy, it was referred to as Ibt Allah, meaning the armpit of the giant, a name that later evolved into Betelgeuse in European languages. The star's cultural symbolism extends beyond its astronomical properties, with ancient civilizations like Egypt and Mesopotamia associating it with deities and cosmic forces. Its position in the Orion constellation, a prominent figure in Greek mythology, further contributes to its cultural allure. From a scientific perspective, Betelgeuse offers a unique opportunity to study the final stages of massive star evolution. As it nears the end of its life, it will undergo complex cycles of fusion, including the creation of heavier elements, before eventually collapsing in a spectacular supernova explosion.